Hey all, Rusty Rob here. Welcome back to the channel. So I just recorded a 150 subscriber special, but turns out I didn't have audio turned on, so that's not good. So we just have this Meta Hacker Cup running at the moment. Still got a couple of days left, but I did a couple of the problems this morning, which was fun. So I'll upload this in a couple of days, but yeah, no audio, so I'm going to record it again quickly. I'm super hungry and I need some lunch, but yeah, this problem, second flight, yeah, there's a bunch of airports, 200,000 airports, 200,000 flights, and 200,000 queries. So there's pretty big numbers in this problem. And so each airport has a morning flight and an afternoon flight of a certain capacity to various other airports. And so for each query, we need to work out how many people can get from a certain airport to a certain other airport based on the query. So yeah, I wrote this down. So let's say N is the number of airports, Q is the number of queries, A was the number of edges, and T is the number of test cases. So you got to be careful. It's quite easy to look at every airport and then look at the flights going from that airport, but then you're already going to be too slow because that's N squared, 200,000 squared. And then if you do that for every query, that's 200,000 cubed. And then multiplied by 100, that's a massive number, so it's not going to work. So we have to break the problem down. So we have to think, I'm just going to make this video a bit bigger. We have to think, can we consider big airports and small airports separately? And the idea is that there can only be a limited number of big airports, because if there are many big airports, let's say there's 200,000 big airports, and each one had a lot of flights going out of it, then you'd have more than 200,000 flights, right? But we know we're limited to 200,000 flights. So it's impossible for every airport to have a lot of flights going out of it. So that, yeah, there's less than the square root, around about the square root. So there'll be about 500 big airports, and no more than that. And so we would consider an airport large if it had more than 500 flights going out of it. You can play around with that number to see what gives you the best performance. And yes, so if we have a different algorithm for big airports and small airports, or we call it heavy and light airports, a light airport, there's a lot of them, but at the same time, they don't have many flights, so our algorithm will run really quickly. So we have the algorithm that we have for small airports, we want it to not look at too many flights, which should be okay. And the one for big airports, we don't really care about efficiency for it because there's not many big airports. So we can pretty much look at every other airport and do some kind of calculation. So let's see, what did I do here? Yeah, heavy airport. Okay, solving for a heavy airport. So for each heavy airport, looked at all the other airports and calculate the flights from the other airport to the heavy airport. You don't want to do it the other way around because, yeah. So since there's only 500 heavy airports, and then we're looking at all the other airports each time, that's 500 times 200,000. And then we're kind of working our way back from the other airport back to the heavy airport through all the intermediary airports. That's just going to be the average number of edges. So this is like average flights. And that's why it's the total number of edges divided by n. And so that helps a lot. Getting that divided by n is pretty critical. So you can kind of think of that as 500 times n. And then solving for the light airports. Yeah, so before we solve for the light airports, we've solved for all the heavy airports and put that into cache, and then we just go through all the queries. And if the query involves a heavy airport, we just grab it out of cache. Otherwise, we do a calculation where we just basically look through all of the flights going from that light airport, and then we look at we look at all the flights, then we use a hash map. So it's 001. So that'll just be the number of queries multiplied by 500, because each query is potentially a light airport, and 500 is just how many, the maximum number of flights that a light airport's going to have, and times 1 because we've got a hash map. So yeah, the totals of the two different calculations will be Q times 500 plus N times 500, which comes out to be about that. And yeah, I'll just walk you through the code quickly. So we're just building up a graph of all the flights. So from A to B has capacity C. We're just setting our heavy threshold as the square root, but you could just type in 500 or something, it'll work. We're just reading all the queries as tuples. So this is saying, it's asking from airport X to airport Y, what is the capacity in a given day? So yeah, now we're building up a cache. So for every heavy airport, so this is what runs 500 times, then we're going for every airport Y. So we could potentially have a query from X to Y, and the answer is going to be the same going from Y to X as it is from X to Y. So then it's important that we go from Y to X. So we start off our total with just the direct flight multiplied by 2, because it's the morning and the evening flight. And then each intermediate airport Z, we get the capacity of that flight to X. And we just take the minimum of the capacity from Y to Z and Z to X and add that to our total. And then we just insert it into our cache. And I just did X, Y, and YX because I wasn't sure which way around the query was going to be. But actually, I can see back here I already swapped them. So one of the two isn't necessary, I guess. Anyway, so that's solved and cached all the heavy queries. And so if we get it from cache, we set it as the answer. Otherwise, we just go through the remaining queries. And this code is pretty much identical to this code up here. And so this could be up to 200,000, but then this is limited to 500 because we know it's a light airport. And that's pretty much it. And then we just print out all the answers, and we do that for all 100 test cases. So yeah, that was a fun problem. It's quite cool when you know a few tricks. I remember the first time I saw a few problems where you kind of do a decomposition and you think about things in terms of like solving it separately for large test cases and small test cases. And yeah, it's quite an interesting way to go. I'm not sure if this is how you're supposed to solve this problem or not, so I'm interested to see the editorial, but it was just the simplest thing I could think of. So yeah, thanks for watching. Feel free to subscribe. I'll catch you next time.